Hey, good day, grade 11s. I hope that you're also glad to be here. Today, I'm going to do a little bit of analytical geometry and I'm going to do revision of the grade 10 analytical geometry. You are going to be asked the same type of things in grade 12 again. The only new thing is inclination angle. We will do that on Monday. And then in grade 12, you will do circle analytical geometry, and that's all that you will learn that's new. So it's important that you understand and that you know the basics. Now, if we speak of analytical geometry, then we are working on the Cartesian plane, okay, the y-axis and the x-axis, and we're working with points on the Cartesian plane. So say I have 2 points there. Now it doesn't matter what I call them. I can call them x1, 1 and 2, or A and B. So let's call this point point A and this point B. And you know that each point has an x coordinate and a y coordinate. So let's call this the x coordinate of A and this one the y coordinate of A. Then this point's coordinates will be the x coordinate of B and the y coordinate of B. Okay, and then they can ask you a few things about those 2 points. They can ask you the distance between the 2 points or the length of the line AB if you would join that line, those 2 points, and it makes a line. They can ask you the distance between the 2 points or the length of the line. And then you must know the formula that I have here, AB equals. Now, first thing is, in grade 11, you're not going to get the formulas. So you must know the formulas by heart. You must study them. You're not going to get them on a formula sheet. The second thing, you must know that if they ask you for AB, it means length. So if they ask AB or CD or EF, it's the distance between those 2 points or the length between those 2 points. And that you can get by the formula square root of, and then the difference between the x coordinates squared plus the difference between the 2 y coordinates squared. It's actually the theorem of Pythagoras. It's nothing but that. And then to get the, you must remember to get the square root of that if you want the distance of AB. Now, before I go to equidistance, I just want to go to midpoint first. So if you have the 2 points A and B, and you want the midpoint between them, okay, you have a formula where you can calculate the midpoint. To get the x coordinate of the midpoint, here they call the midpoint M. So they call the midpoint M. So we're going to calculate the x value of M and then the y coordinate of M. So you just add the 2 x coordinates and divide by 2. It's like calculating average. You understand? How do you get average? Mean. You just add and then you divide by how many values you have. So if you take the 2 x values and you add them and you divide by 2, you're going to get the x coordinate of the midpoint. If you add the 2 y coordinates and you divide by 2, you're going to get the y coordinate. Now I want to come back to equidistant. Equidistant means the same distance, the same distance. Now, yes, it is true that the midpoint is also equidistant from 2 other points. But that's just one specific case. The midpoint is just in the middle of a straight, when 2 points are in a straight line. Okay. But that's not what equidistant mean. Equidistant mean 2 points, two lengths are exactly equal, doesn't matter where the two lines are. So if they say P is equidistant from points A and B, then you please don't work with the midpoint formula. You say, okay, P, the distance from P to A, so the distance from P to A is the same as the distance from P to B, the same as the distance from P to B. Okay, and can you see that point P is definitely not in the midpoint of A and B, because then A and B must be in a straight line and P must be on that line. Okay, so equidistant, you work with the distance formula. So if they ask you anything about length or distance, you work with the distance formula. Okay, then they can also ask you the gradient. Now the gradient means how steep the line is. Are you climbing or are you descending? Okay. Now, I don't know if you have heard of rise over run. Rise over run. How you rise over the distance that you're taking gives you the gradient. Okay. So, how do you get the gradient between any 2 points? You take the y values and you subtract them. You must start with the y's on top. In science, you say delta y over delta x. I don't know if you have science. So it's the difference between the two y values divide by the difference between the two x values. Now, what's important is that if you start with point B at the top, you must start with point B at the bottom. So if you use the y coordinate of B, then you must start with the x coordinate of B. Then you subtract the y coordinate of A and you subtract the x coordinate of A. So can you see there's one point and there's another point. That's important because if you swap, then it's wrong. You can start with the y coordinate of A minus the y coordinate of B, but then you must start with the x coordinate of A and subtract the x coordinate of B. That's acceptable because this is still the one point and that's the second point. So it doesn't matter with which point you start. That does not matter. But you must start with the same point in the numerator and in the denominator. And it's y's on top and the x's at the bottom. Okay, so that was gradient. Yes, and what I also want to say about gradient, please use your logic and make sure that whatever you calculate makes sense. You know that this line is going uphill. How do you read? Well, I have a little bicycle on my board, okay? And then I say, okay, we come with a bicycle. If we hit that line, what will happen? We go up. So it's a line with a positive gradient, a positive gradient. So make sure that if you calculate the gradient, that it is in fact positive. And then if a line looks like that and you come with your bicycle, what's going to happen? You're going to go down. So that gradient is negative. That gradient is negative. So make sure that if you calculate the gradient, that the gradient really fits the line. Don't calculate and get a negative answer while it's an uphill line. If you know that there's a mistake, then you can fix it. And how do we read the gradient? As we read a storybook, from left to right. We come from the left-hand side. If we hit the line, we go up. We come from the left-hand side. If we hit the line, we go down. Okay. Then, when will you use gradients? Whenever they ask you anything about parallel lines, perpendicular lines, or collinear points, then you know you're going to calculate gradients. Okay. Now, why is that important? Parallel lines, remember what I said, what does gradient mean? It means how steep the line is. Now, if you have parallel lines, don't they have the same steepness? That's what parallel lines mean. So that means the parallel lines have the same gradients. So parallel lines have equal gradients. So if this gradient is, say, 2/3, then this gradient will also be 2/3. What do you know about perpendicular gradients? The gradient of the one times the gradient of the perpendicular line will give you an answer of -1. What does that mean? If this gradient, the gradient of CD, is, say, 2/3 again, well, it's an uphill gradient, it's a positive gradient, so I can say it's 2/3. What will be the gradient of AB? The gradient of AB will be negative the inverse. Negative the inverse, or negative the reciprocal. Now, can you see? This line is uphill. It has a positive gradient. That line is downhill. It has a negative gradient. So you cannot have perpendicular gradients with the same sign. It's impossible. Okay? So if this gradient is positive, the perpendicular line's gradient will be negative, and the one will be the inverse, or the reciprocal of the other one, because the one times the other one will give you an answer of 3's cancel, 2's cancel. It will give you an answer of -1. So whenever they ask you anything about perpendicular lines or a right angle, you hear the word right angle, you know that you're going to work with gradients. And then what does collinear points mean? Collinear points mean points on the same straight line. On the same straight line. That's what collinear mean. Points on the same straight line. Now, what's true if that is true? Can you see that when A, B, and C is on the same straight line, they have the same steepness. They have the same steepness. So the gradient between A and B and the gradient between B and C will be equal. Or, for that matter, the gradient between A and C. So those three gradients are all equal. Now, if you have to calculate something about collinear points, or you have to prove that you have collinear points, you don't have to calculate 3 gradients. 2 is enough. 2 is enough. The secret is that you use 1 point twice. That you use 1 point twice. You use 1 point twice. Okay. So look at AB and BC. If you calculate the gradient of AB and BC, can you see that you're using the point B twice for this gradient and for that gradient? Or if you want to calculate the gradient of BC and AC, what are you calculating? Which point are you using twice now? Now you're using the point C twice. So as long as you use one point twice and the gradients are equal, you have collinear points. Okay, good. Then you have the equation of a straight line. Now, the one that I think that you're used to is the equation y equals mx plus c. And you know from grade 8 that m stands for gradient, and you have a formula that you can calculate that with, y2 minus y1 over x2 minus x1. Yes, Mashlatse, you can ask me. Mashlatse, if you want to ask a question, you're welcome. Okay, perhaps I have answered the question. So gradient, m is gradient, and you have the formula y2 minus y1 over x2 minus x1 that you can calculate the gradient with. C stands for the y-intercept. And what does y-intercept mean? It's where your line cuts the y-axis. That's what y-intercept means. Now, usually you will not have the y-intercept. So that's what you're going to calculate. And the most important thing is, if you understand what x and y stand for, then you will also understand graphs that we will do after analytical geometry. So this x and this y stands for the coordinates of any point on that line. There's millions of points, as long as you have one point. So x and y stands for the coordinates of a point on that graph. Okay, so if you have a point, so you have that point, then you can substitute it in the place of x and y. Then you either have to have C, or you have to have another point so that you can calculate the gradient. We will do some examples now. Before I go to horizontal and vertical, I just want to do the other equation again. I don't know if you know this equation. Y minus y1 equals mx minus x1. That's also the equation of a straight line. And both of them give you the same answer, where m is still the gradient. And now you keep x, x, and y, y. So this x1 and y1 are the coordinates of a point on that line. So it doesn't matter if you have a point and another point and you can calculate the gradient and you use any one of the 2 points. Doesn't matter. Both equations, this equation as well as this one, will give you the same equation of the same straight line. And you can choose whichever one you like. Okay. Now they catch you very easily with horizontal and vertical lines. So I give you this blue line here, and I say, please give me the equation. And then you start in calculating gradients, and you try to use the formula, and you do a lot of work, and it's totally unnecessary. Because if you can just go and study, remember maths is a lot of study work. A horizontal line, where does that line go through? It goes through the y-axis at, in this case, 5. And that's exactly the equation. Y equals 5. Y equals a constant. That value where it passes through the y-axis. So I'm saying again, horizontal line, where does it go through? Through the y-axis, where? At 5. So the equation is y equals 5. You don't do any calculations, nothing. You don't do any calculations. You just write it down. And then the same for a vertical line. If I give you this green vertical line, and I say it's going through the x-axis at 4, what's the equation of that line? You don't calculate anything. You just say, this equation is x equals 4. It passes through the x-axis at 4, so the equation is x equals 4. And you can somehow write here, what's the gradient of a horizontal line? Well, the y values stay the same. So whatever y minus y will give you a 0 on top. 0 divided by anything is 0. So the gradient of any horizontal line is equal to 0. And what's the gradient of a vertical line? Well, now the x values stay the same everywhere. So now you have the x's under the line, and that will give you a 0 under the line, and you cannot divide by 0. So the gradient of any vertical line is undefined. The gradient of a horizontal line is 0, and the gradient of a vertical line is undefined. If you try to calculate that with 2 points, you will see why it's like that. So the equation of a vertical line is just x equals a constant. Don't let that catch you with that. Okay. Now let's start with a few sums. Given the points A minus 1, 2, and B15. Now, because you're working with analytical geometry, you're doing analytical geometry, it's always, if you don't know what's going on, or if you just want to so that it makes more sense to you, plot it on your set of axes. It really makes life so much easier. So A is the point minus 1, 2. It's more or less there. So A is the point minus 1 and 2. And B is the point 1 and 5. It's more or less there, so B is the point 1 and 5. That's the given. Now they're going to ask you a few stuff. Calculate the length of AB. So the length of AB, you know that you're going to use the distance formula. Whether you want to start with the A or the B or the X or the Y, doesn't matter. So if I say X of A minus X of B, and I square it, plus Y of A minus Y of B, and I square it, I will get the length. Now please take note. Here, you are going to square, and a square can never be negative. It's always positive. Here you square, a square is negative, never negative. It's always positive. Now you add a positive to a positive. So the answer under this cert must be a positive. Otherwise, you made a mistake. And then go and find your mistake. Okay, so let's substitute. Now, I like to square the left side and the right-hand side. Why? Because then this square root sign falls away and I don't have to draw it all the time. Okay, so if I square the left-hand side, I can leave out the square root sign. So now I substitute 5, what did I write? XA minus XB. XA minus XB. Okay, so it's minus 1, minus 1. So it's minus 1 is the x coordinate of A, minus, and 1 is the x coordinate of B, square it, plus the y of A is 2, minus the y of B is 5, and I square it. So that gives me minus 1 is minus 2, and I squared it. Now you remember I said, if you square any number, it will become a positive. Now I add 2 minus 5 is minus 3, and I square it. So minus 3 squared is 9. And now I have 13. But that was AB squared. So to find AB, I just square root again. And remember, a length is always positive. It cannot be negative. Now, usually in analytical geometry, we leave the answers in third form. So if they say nothing, just leave it in third form. Okay, that was number A. For B, they ask you the coordinates of M, the midpoint of AB. So if I can look on the sketch, if I connect those 2 points, the length will be square root of 13. Now they want the midpoint. So they called it M in this case. So they say M is the midpoint, find the coordinates of the midpoint. I'm just going to do it there. So what did we say to get the midpoint? To get the x of the midpoint, we add the 2x coordinates, minus 1 plus 1, and we divide it by 2. That gives us a 0 divided by 2, which is a 0. So it's on the x-axis, on the y-axis. Now I must still calculate the y coordinate of M. So to do that, I add the 2 y values, 5 plus 2, divide by 2. That gives me 7 over 2. And the coordinates of the midpoint will then be the x coordinate is 0 and the y coordinate is 7 over 2. Good. Calculate the gradient of AB. Okay, what I wanted to say, does it make sense? 0 and 3.5. Yes, it looks as if it can be 0 and 3.5. So my answer makes sense. For analytical geometry, it's easy to see if you made a mistake. If you just look what you're doing, don't just carry on and don't think about what you're doing. Because if you look what you're doing, you will see that somewhere there's a mistake. And then if you know there's a mistake, you can go and find your mistake. Okay, calculate the gradient of AB. So now I want the gradient. They're asking me the gradient. Now, can you see from my sketch that the gradient will be positive? It's an uphill line, so my gradient must definitely be positive. So if I don't get a positive answer, something is wrong. Okay, so the gradient between A and B, can you see how I write it? Work neatly, because then it's easier for you to revise and it's easier for your teacher or the examiner to examine your marks and give you a better mark, because they can read actually what you're doing. Okay, so now I say the y value, doesn't matter if I start with A or B. Say I start with point B minus the y of A. Then I must start with the x of point B minus the x of point A. So that will give me, it's 5 minus 2, 5 minus 2. I must start with a B point first. So now it will be the x coordinate minus the x coordinate. So it is 1 minus minus 1. So that gives me an answer of 3 over 2. Okay, now number D. They say if B is the midpoint of AC, calculate the coordinates of C. So that means now they tell me B is the midpoint. So there's AB. So that means I must lengthen that line. Now I don't have enough space there. I must lengthen that line to get a point C, so that B is the midpoint. Now they don't ask me the midpoint, they give me the midpoint. So I'm just going to use the midpoint formula again. And I'm going to say B, or that 1, is the midpoint of minus 1 and the x coordinate of C, and the same for C. So I'm going to say for number D, I'm going to say the midpoint of A and C. So the x coordinate of A was 1, plus the x coordinate of C, I don't know, that's what I want. Divide by 2 is equal to the x coordinate of B. And what is the x coordinate of B? It's 1. And the y coordinate of A plus the y coordinate of C divided by 2 is equal to 5, which they gave me. And now I have two equations that I can just solve. Now, if you have equations, it's easier to make fractions all the way, because then you can cross multiply. So if I cross multiply, I get minus 1 plus x of C is equal to 2 times 1 is 2. So x of C is equal to, take this minus 1 to the other side, 2 plus 1 is 3. Do the same here, make it a fraction and cross multiply. 2 plus yc times 1 stays. 2 plus y of C equals 5 times 2 is 10. Take the 2 away, take it to the other side, it becomes a minus. 10 minus 2 is 8. So now I have the x coordinate of C, the y coordinate of C. So C is the point 3 and 8. So I'm using the midpoint again. It's just sort of in reverse. Now, in number E, they ask me, show that A, B, and P are collinear if P is the point 5, 11. Now, remember what collinear means? Collinear means A, B, and P is on this, must be on the straight line. So P is also on this line, somewhere there on top. I don't have enough space. So somewhere I have a point P, 5, 11, and I must now prove that they are on the same straight line. What's the easiest way of proving that? With gradients. So you must use the points A, B, and P and calculate two gradients. So say I calculate the gradient of AB and the gradient of BP. Let's see what happens. So I'm going to calculate the gradient of AB and I'm going to calculate the gradient of BP, and I'm going to see if I get the same. So my points A and B, you remember the formula, y minus y over x minus x. If I use the 2 points, I get 5 minus 2 over 1 minus 1, and that was 3 over 2. That I calculated now already. Now I calculate the gradient of BP. Now they've given me the point P, so it's 11 minus B is 5, and then 5 minus 1. That gives me 6 over 4. But can't I simplify that? If I divide by 2 and divide by 4, I get 3 over 2. Now can you see here, the two gradients are equal. So therefore, the points A, B, and P are collinear. So that's how you will prove that you have collinear points. Okay, are you okay that I can carry on? Good. Now we have an interesting one here. And they love to ask something like this. For which value or values of t are the points A, which is now t and 3t, and B, which is t plus 3 and 2t, and C, which is 10 and t minus 1, collinear? For which values of t are the points collinear? Can you see how it differs from the previous one? The previous question is show that the points are collinear. So you calculated the two gradients and they were supposed to be the same. Now they say calculate the value of that t so that the points are collinear. So what are you going to do? You're going to calculate the gradient of AB, and you're going to calculate the gradient of, say, BC, and you're going to equate the two gradients. So let's calculate the gradients. Now remember again, if I start with this point first, then I must start with the y first and then the x first. So gradient of AB, y of B is now 2t minus the y of A is 3t over the x of B is t plus 3 minus the x of A is t. So if I simplify that, 2t minus 3t is minus 1t. And can you see the t and the t here will cancel? And I'm left with a minus t over 3. Now I'm going to calculate the gradient between two other points, say BC. So say I start with C, then I must start with C at the top and C at the bottom. So let's start with C. So the y value, the y coordinates are t minus 1 minus the t value, the y value of B, that's 2t. Then I take the x coordinate of C minus the x coordinate of B. Now, because it's a two term, remember to put it in brackets, because remember a minus in front of a two term or a three term is danger. Because if you don't remember to multiply in that minus everywhere, you're going to make sign mistakes. So let's look what happens here. T minus 2t is minus 1t, and there's a minus 1. Then, okay, minus t minus 3. 10 minus 3 is 7, and then there's a minus t. It looks terrible, but that's exactly what you have to do. So you first calculate the gradients, and what do? You equate the gradients for collinear points. So you're going to say, okay, this gradient here, minus t over 3, must be equal to this gradient here. And because it's fractions, if a fraction is equal to a fraction, we can cross multiply. So now I'm going to cross multiply. So I'm going to take that minus t and I'm going to multiply it with this 7 minus t. I put it in brackets because it's a two term. I'm going to take this 3 and I'm going to multiply it by minus t minus 1. And I'm just going to solve. Remember, geometry, trigonometry, analytical geometry, statistics, they are all based on algebra. They use algebra to simplify. So now it's just simple algebra. So now multiply gives you minus 7t plus t squared equals minus 3t minus 3. You have a square there. How do you solve a squared equation? You bring everything to the one side so that you can get a 0 at the other side. So if I write that t squared first, now minus 7t, I take this minus 3t to the left, it becomes a plus 3t. So minus 7t plus 3t is minus 4t. And I bring this minus 3 to the left, it becomes a plus 3. Why do I do that? So that I can factorize. Or you remember, if you can't factorize or you can't see the factors, you can always use the formula, quadratic formula. But I can factorize t times t, 3 times 1, and I want a minus 40 in the middle. So minus 3t minus 1t will give you a minus 4t, and minus 3 times minus 3 will give you that positive 3. So that works out. So this bracket is equal to 0, or that bracket is equal to 0. So now that will give me t is equal to 3, or t is equal to 1. So there's actually two different points that can work. Okay. So it looks difficult, but if you know the rules, if you know the recipes, and you know what to do, I must calculate gradient, I must calculate gradient, I must set them equal, and now it's just algebra further. Okay, let's go to example 3. They also like to ask questions like this. Given the points, now they're giving you A is minus 2 and 1, B is 1 and 3, C is 5 and negative 3, and D is minus 1 and K. There's a K. So that value K you don't know. So you can move the point so that you do whatever they ask you to do. Determine the value of K if. Now they want AB to be parallel to CD. Can you remember what I said about parallel and perpendicular lines? You know that you're going to work with gradients, because if you go back a few pages, what do you know about parallel lines? They have the same gradients. So you're going to work with gradients. Okay, so you're going to calculate the gradient of AB, and it must be equal to the gradient of CD. So now we're just going to calculate gradients again. So the gradient of AB is y minus y over x minus x. So let's write it. So the y minus the y is 3 minus 1 over 1 minus minus 2. Let's calculate the gradient of CD. CD, so it's y minus y over x minus x again. So the y value of D is k minus the y value of C is minus 3 over, I must start with the D coordinates again, minus 1 minus 5. So I just simplify. 3 minus 1 is 2, 1 minus minus 2, 1 plus 2 is 3. Can I simplify a little bit? Yes, I can. K, it will become K plus 3. And here it will become a minus 1 minus 5 is a minus 6. What do you know if you have a fraction equals a fraction? You can cross multiply. So cross multiply, that will give you 3 times K plus 3 is equal to minus 6 times 12 is minus 12. So that will give you 3K plus 9 is equal to minus 12. Now you just solve. Can you see now it's just algebra? So 3K is equal to minus 12. Take the 9 to the other side, minus 9. That will give you minus 21. And to get rid of the 3, you're just going to divide by 3, and you're getting k as minus 7. So if you move that point so that k is minus 7, you will have parallel lines. Now the second option, or the second question, they give you the same points, Now they say, but now move point D so that AB is perpendicular on CD. So what do you say? You know, for perpendicular lines, you are going to work with gradients again. And you know that the gradient of AB times the gradient of CD must give you an answer of -1. I'll show you an easier method just now. So I have the gradient of AB already. There's the gradient of AB. So I'm not going to calculate again from scratch because I have it already. So I'm just going to say, okay, the gradient of AB is 2/3. Gradient of CD. I have the gradient of CD already. There it is. So times k plus 3 over minus 6 must give me an answer of -1. Now, if you know enough of fractions, if there's a multiplication between fractions, you can cancel. Can you see that 2 go into ones, 2 go into 6, 3 times? Can I do that? Yes, I can. As long as I do in the numerator what I do in the denominator, I can almost do it. So if I work with smaller numbers, there's less places that I can make mistakes. So I just like to work with smaller numbers. So 1 times k plus 3, how do you multiply with fractions? Numerator times numerator over denominator times denominator. So 1 times k plus 3 is k plus 3. 3 times minus 3 is minus 9. That's equal to, make that -1 a fraction again, because if you have a fraction equals a fraction, you can cross multiply. And if I cross multiply, I get k plus 3 is equal to -9 times -1 is +9. So then k is equal to 9 minus 3 is 6. They love asking you questions like this. And although it's number A and B of the same sum, it's totally two different answers because they ask you two totally different questions. Okay, let's carry on. They say the point X, the point P, which is X and -1, is equidistant from the points A, which is -4, -2, and B, 8 and -4. Determine the value of X. Now, if I can just show you what this means. There's your set of axes. A is the point -4, -2, so it's more or less here. So say that's the point A, -4, -2. B is the point 8 and -4. So 8 and -4 is more or less, say, about there. So this is the point B, 8 and -4. Now they say there's a point P, which is x and minus 1. What does that mean? I don't know where's that point, but I know it's on the line where y is equal to minus 1. Now, what does y equals minus 1 look like? It's a horizontal line through y equals minus 1. So that point P is somewhere on this line. So that point P is the same distance from A and from B. So it will be something like that. Can you see? That's what it actually means. So now let's calculate. Please don't use the midpoint formula because those 3 points are not in the same on the same straight line. So I must use the distance formula. So can you understand that the distance of AP will be equal to the distance between P and B? Distance between A and B will be equal to the distance from P to B. And I know that P is the point X and negative 1. So I'm going to use the distance formula. So I'm going to say I take the x's first. So x minus minus 4, x minus minus 4 squared plus y coordinates minus 1 minus minus 2 squared. Now remember, there's actually a square root sign, but do I have to write it? No, I don't have to, as long as I square the right-hand side as well. Okay. Okay, I'm going to leave it like that because now I cannot, otherwise I must rewrite it. Okay, so now let's calculate the length of PB. So this is x minus 8 squared plus y minus 1 minus minus 4 squared. Now I'm going to carry on without the square roots because if I square the left-hand side, the square roots, the square and the square root fall away. And if I square the right-hand side, the square root and the square falls away. And I can carry on without the square root signs. Now, please don't tell me that the square of x plus 4 is x squared plus 16, because it's not. A 2-term squared gives you a 3-term. You must write the bracket twice and FOIL. You remember that? So it will give you x squared plus 8x plus 16 plus minus 1 plus 2 is 1. 1 squared is 1. 8 minus x squared, 2 terms squared is a 3-term. Write the bracket twice and FOIL. So that will give you x squared minus 16x plus 64. 4 minus 1 is 3. 3 squared is 9. Now, can you see now it's just algebra further? Can you see that the x squared and the x squared will cancel? If I take the x's to the left, there's an 8x and a minus 16x. If I take the minus 16x to the left, 8 plus 16 is 24x. Yeah, I will have 73 minus 17. That will give me 64. 72. No. 73 minus 7. No, something's wrong here. Minus, okay, minus 4. You know what? That was not supposed to be a minus 4, but in any case, now I have it. So 73 minus 17 will give me 16. Is that right? Okay, 56. 56. Is that right? So now my x will be 56 over 24. And if I simplify that, I can divide by 4, and I can divide by 4, and I can divide by 2 again, 7 over 3. Yes. Okay. So now it's just algebra. But the beginning was analytical geometry, and then I just carry on with algebra. Okay, let's look at example 5. Determine the equation of the line parallel to the line y equals 2x minus 3 through the point 1 minus 4. So I want the equation of a line. Now I will do the two with the two different formulas that you can see. I'm going to do this one with the equation y equals mx plus c. Now, what do you know about parallel lines? They have the same gradients. And where do you find the gradient? In front of the x, there's the gradient. If my equation is in standard form. Now, is this equation in standard form? Yes, it is. So there's the gradient. Parallel lines have the same gradients. So this gradient must also be 2. They say through the point 1 and minus 4. What did we say now about this x and y? It stands for the coordinates of a point on that line. Do I have a point? Yes, they're giving me a point. So I'm going to substitute the x with 1 and the y with minus 4 so that I can find the c value. So that will give me c equals minus 4 minus 2 is minus 6. So therefore my equation is y equals, gradient is 2x minus 6. If I look at number B, look what they're asking me now. Perpendicular to. Perpendicular to. So what do I work with if I see the word perpendicular? With gradients. So I first have to find the gradient of this line. Now this line, is that line given in, is that equation given in standard form? No, it's not. So I must first get it in standard form. That means I must get the y alone. So I'm going to do everything to get the y alone. So I'm going to take this 2x to the right-hand side. I'm going to divide that minus 3 away. That's minus 2 over minus 3x plus 7 over minus 3. Now, can you see that minus and that minus cancels? So I have the equation 2/3 x minus 7 over 3. Do I know what the gradient is now? Yes, I know this gradient is 2/3. But what do they ask me? The line perpendicular to that line. So if this gradient is 2/3, the gradient of the perpendicular line is, can you remember we said now, if the one line is positive, the perpendicular line will have a negative gradient. And if this gradient is 2 over 3, the perpendicular gradient will be the inverse, the reciprocal, 3 over 2. So now I have the gradient and I have a point. Now if I use, I'm going to use the other formula that you can see that it works. Substitute, you know the new gradient is minus 3 over 2. You keep the y, and you keep the x. And what is this? What's the meaning of this y1 and x1? It's the point that you want to use. So I'm going to substitute that point, minus 4 and 3. So x I substitute with minus 4, and y I substitute with 3, and I simplify. If I multiply in, I get minus 3 over 2x, minus 4 become a plus, times that minus is a minus again. Now 2 going to 4 2 times 3 is 6. If you don't do it in your head, then you can use your calculator. And I want y alone, so I take this minus 3 to the other side as a plus 3, and negative 6 plus 3 gives me negative 3. Okay, I see you not tomorrow, on Monday afternoon, 3 o'clock again, and then I will be carrying on with analytical geometry again. Enjoy your weekend, stay safe. See you Monday afternoon. Bye-bye, class.
Bye.